In this section we're going to be taking a look at noise texturing in the render tree. Noise forms the basis for the texturing of many natural phenomena. You'll have seen them in computer animation, computer graphics all over the place. Marble in particular is quite common. You'll also see it being used for clouds, wood, terrain. All of these use noise in one form or another as the basis of the images that are produced. XSI render tree comes with a number of noise-based nodes. There's some marble in there, there's cloud, there's turbulence. These are all noise-based things. We're not going to use those. We're going to use very, very basic, quite primitive noise nodes, two of which have been written specifically for these exercises. There's a noise node and there's a turbulence node. And we're going to use these to build up more complicated textures, including marbles and stone type textures, and we're going to be using them for modifying some of the existing texture nodes in the render tree. First of all though, let's just take a look at the nodes by way of introduction. Again here a sphere with a Phong shader applied to it, and we'll take a look in the render tree. There's the Phong shader. And let's get one of these nodes in. We have to get it through a file browser because they're not part of the nodes menu, being third-party nodes. I'm going to get them from the workgroup application path because I've got them installed there, but when you install them on your CD you'll find them in exactly the same way as we're going to get them now, but under the user workgroup, under the user application data path. There are two nodes there. Take a look at the noise node first. There, and its property page. It has a color input. It has a coordinate input, which I'll come back to in just a second. Frequency in UV and W. Remember, noise is a three-dimensional function, very much like the marble functions and the cloud functions that you see in Softimage 3D that you're probably familiar with, and an offset, three offset parameters used for just simply shifting the texture. The coordinate is the UV coordinate input. Like I said, this is a very simple, quite raw texture node, unlike some of the ones that we've been dealing with here. These ones have already got all of the UV inputs built into them. This one requires that you put your own UV node into it, partly for simplicity, but also there are some advantages to doing that, which you'll see later on in this section. Okay, to do that, we get a texture space generator, and we get a generator. It's exactly the same, in fact, as these textures we've been using earlier, and in fact those textures are combinations of these nodes. They've been packaged together all into one node. So the noise node plugs into the coordinate there. The noise RGB will plug into the diffuse so that we can see it. And the texture generator, there we go, we can create a texture space in here. We can use an existing projection method, any of these down here, spherical, whatever. We're going to get a new spatial projection, and we're going to disable the projection method there. So we're going to use the texture space that we've created. We're using a spatial projection because this is a three-dimensional texture. We want to be able to see it fully in 3 dimensions. We can use normal flat projections or cylindrical projections, but by using a spatial projection we don't get that nasty streaking down the side, and it just looks more natural and it's easier to deal with. Okay, back to the noise node, its property page there. Open up a render region and we can see what it looks like. I'm just going to take the highlight off that Phong node to make things a bit clearer. Not hugely interesting in itself, but it will be later on when we start using it with other textures. Increase the frequency, and you can see more detail in there. If I shift it, if I add values into the offsets here, you'll see it move. Not really very much. And the colour there for changing the colour. Like I said, not hugely exciting, but it can produce some quite startling results, which we will see later. The second node, again, pick it up in exactly the same way. Remember that you'll be getting it from the user application data path. I've got it from the workgroup path. Turbulence. That's the turbulence node there, and that's his property page. Let's plug it in first and take a look before we go through that property page in detail. Again, it needs a text-to-space generator of some kind in there. We'll use the one that we've already got. Plug that into the diffuse, and you can see considerably more interesting. I'll just bring the colour down so you can see the detail a little bit better. Now, turbulence is in fact based upon noise. What happens in a turbulence function is that the noise function is called several times with successively increasing frequencies and added into the colour of the object at that given point. So you get increasingly higher frequencies of noise added into the surface, and that's how you get that extra kind of cloudy detail there. You can already see how they're starting to look like cloud in there, and that's why we have an octaves parameter in there. If I turn that right down to 1, you can see that there's just one noise function being called there, and that's very similar to the noise image that we saw here. As I increase the value of octaves in there to 2, that's an integer, not a floating point value, you can see more detail getting added into it, turning it up to 3, a little bit more detail, 4, a little bit more detail, and what it's doing is it's adding in noise at increasingly higher frequencies. Changing the frequency there, that's changing the overall frequency of the texture. All of the noise functions are being increased in frequency. These two functions here, lacunarity and gain, without getting into too much detail, those two parameters control the way in which the frequencies are increased as they're added in, and multiplication, the way the values of those noises are increased as they're added in as well. They're basically multiplying frequency and value. The effect of that is increasing it. Effectively increases the detail in there. It makes it a little bit grainier. If I change the grain in there, you can see more detail being added in there. Just bring the value down so that you can see the detail there. So you've got quite a lot of control over the level of detail that you're putting into it. So that's the two basic functions. Now, with these two functions, we're going to be using them with only a few other texture nodes in here to produce quite a wide range of textures, including marbles, messing around with existing textures, perturbing them, all sorts of really quite exciting things. Those we'll look at in the next video, though. This is just an introduction, and that's noise and turbulence.